The last objective for AZ-304 is design infrastructure. And it's about a third of the total exam, so actually it's the largest section that you'll probably want to take focus on, unless it's something you're already familiar with. Another recommendation I made, since these sessions are being modularized, in other words, you can watch separate recordings later on each of these individually, I would take a look also, if this is a weak area of yours, to focus on the individual recordings, and there were 2 of them in the AZ-303 because infrastructure in the AZ-303 is half of that exam. So keep in mind the difference between the 303 and the 304 is 303 is more implementation, where 304 is more design. So often when you're doing implementation, the capabilities and the reasons why you choose those things ultimately help to determine the design. So really studying both exams is very complementary. And again, you can pick these modules that are similar in each exam because they have similar titles, just different verbs. And again, in AZ-303, we had this great eye chart, decision tree at the bottom. You must go through this, and we've had several different parts that we've talked about here in knowing the pros and cons of one service. And again, as a reminder, neither service fabric nor batch services are covered as they were in the past. So you don't have to worry about those on this exam. This one, we blew up the slide in this section, which gets kind of a decision tree. Again, we could scratch off batch and service fabric, but everything else is game. So are you doing lift and shift or cloud optimize? Do you need full-fledged orchestration? Yes or no? If it's a yes, we go down straight to the middle and the bottom, and we go to Azure Kubernetes Service. Do we need web apps? Do we need to be containerized? Microservices architecture. So these are really great design decisions. I kind of learned this eye chart with the exception of batch and service fabric, and use this as a mental guide in figuring out which option you should go to based on the requirements that they may give you in this exam. Recommending the AKS solutions. Let's drill down in this a little bit. In order to build and run applications successfully in Azure Kubernetes Service or AKS, there's some key considerations to understand and implement. These areas include multi-tenancy and scheduler features, cluster, pod security, or business continuity and disaster recovery. If the resource needs of your application change, you can manually scale an AKS cluster to run a different number of nodes. When you scale down, nodes are carefully cordoned and trained to minimize disruption to running applications. But when you scale up, AKS waits until nodes are marked ready by the Kubernetes cluster before pods are scheduled on them. As part of the life cycle of an AKS cluster, you often need to upgrade to the latest Kubernetes version. It's important that you apply the latest Kubernetes security release or upgrade to get the latest feature. This link provided will show you how to upgrade the master components or a single default node pool in an AKS cluster. A proximity placement group is a logical grouping used to make sure Azure Compute resources are physically located close to each other. Some applications like gaming, engineering simulations, and high-frequency trading or HFT require low latency and tasks that complete quickly. For high-performance computing or HPC scenarios such as these, consider using proximity placement groups, PPG, for your cluster's node pools. Make sure to note the limitations on this link. To rapidly scale application workloads in an AKS cluster, you can use virtual nodes. With virtual nodes, you have quick provisioning of pods and only pay per second for their execution time. You don't need to wait for Kubernetes Cluster Autoscaler to deploy VM compute nodes to run the additional pods. Note that virtual nodes are only supported with Linux pods and nodes. The virtual nodes add-on for AKS is based on the open source project Virtual Kubelet. There are many best practices to review. You'll have to weigh your study time against the weight of this section, remembering that this section is only 10 to 15% of the exam. Windows Virtual Desktop is a desktop and app virtualization service that runs on the cloud. When you run Windows Virtual Desktop on Azure, you can do the following. You can set up multi-session Windows 10 deployment that delivers a full Windows 10 with scalability. Virtualize Microsoft 365 apps for enterprise and optimize it to run in multi-user virtual scenarios. You can provide Windows 7 virtual desktops with free extended security updates. Bring your existing remote desktop services, or RDS, and Windows Server desktops and apps to any computer. You can virtualize both desktops and apps. Manage Windows 10, Windows Server, and Windows 7 desktops and apps with a unified management experience. Containers are becoming the preferred way to package, deploy, and manage cloud applications. Azure Container Instances, or ACI, offers the fastest and simplest way to run a container in Azure without having to manage any virtual machines and without having to adopt a higher level service. Azure Container Instances is a great solution for any scenario that can operate in isolated containers, including simple applications, task automation, and build jobs. For scenarios where you need full container orchestration, including service discovery across multiple containers, automatic scaling, and coordinated application upgrades, we recommend Azure Kubernetes Service, or AKS. Azure Container Instances enables exposing your container groups directly to the internet with an IP address and a fully qualified domain name. When you create a container instance, you can specify a custom DNS label name so your application is reachable at a custom label.azure region.azurecontainer.io. Azure Container Instances also supports executing a command in a running container by providing an interactive shell to help with application development and troubleshooting. Access takes place over HTTPS using TLS to secure client connections. In the hidden slides of this deck, there are many slides addressing this section. It's very large, so you'll want to review those once you get the deck and look at the hidden slides. For these new slides, I'm focusing on things I didn't previously address in older deliveries of this section. So let's start with Azure Virtual WAN, which is a networking service that brings many networking, security, and routing functionalities together to provide a single operational interface. These functionalities include branch connectivity via connectivity automation from virtual WAN partner devices such as SD-WAN or VPN CPE, site-to-site VPN connectivity, remote user VPN connectivity, private ExpressRoute connectivity, intra-cloud connectivity, VPN ExpressRoute interconnectivity, routing, Azure Firewall, and encryption for private connectivity. You do not have to have all of these use cases to start using Azure Virtual WAN. You can simply get started with just one use case and then adjust your network as it evolves. The Virtual WAN architecture is a hub and spoke architecture with a scale and performance built in for branches, VPN, SD-WAN devices, users, ExpressRoute circuits, and virtual networks. It enables global transit network architecture where the cloud-hosted network hub enables transitive connectivity between the endpoints that may be distributed across different types of spokes. Azure regions serve as hubs that you can choose to connect to. All hubs are connected in full mesh in a standard virtual WAN, making it easier for users to use the Microsoft backbone for any spoke connectivity. Azure Private Link enables you to access Azure PaaS services, for example, Azure Storage and SQL Database, and Azure hosted customer-owned partner services over a private endpoint in your virtual network. Traffic between your virtual network and the service travels the Microsoft backbone network. Exposing your service to the public internet is no longer necessary. You can create your own private link service in your virtual network and then deliver it to your customers. In this link on the slide, it would be worth a scan through in the Azure Docs to see the supported services, particularly if you're new to this. In the extra hidden slides, there are many links to various network management tools. Make sure to review these and know the differences between their capabilities. In particular, know all the capabilities of Azure Network Watcher and also the three broad capabilities of Network Performance Monitoring, or NPM. Both of those links are provided at the bottom of the slide for your convenience. In designing an application architecture, there are many possibilities and considerations. For the exam, you have some homework here to do. But once again, the links to help you study are all right here. Review the comparisons and overview of the services to get a basic idea of when and why you would choose one over another. Likewise, many of the links in the microservices architecture section provide orchestration options. Be familiar with the logic apps and functions link, plus the additional ones under orchestration solutions on the slide to understand the pros and cons of the various orchestration capabilities for Azure deployments. In a microservices architecture, a client might interact with more than one front-end service. Given this fact, how does the client know what endpoints to call? What happens when new services are introduced or existing services are refactored? How do services handle SSL termination, authentication, and other concerns? An API gateway can help to address these challenges. An API gateway sits between clients and services. It acts as a reverse proxy, routing requests from clients to services. It may also perform cross-cutting tasks such as authentication, SSL termination, and rate limiting. If you don't deploy a gateway, clients must send requests directly to front-end services. Azure Migrate provides a centralized hub to assess and migrate to Azure on-premises servers, infrastructure, applications, and data. It provides the following: a single portal to start, run, and track your migration to Azure, a range of tools for assessment and migration. Azure Migrate tools include Azure Migrate, Server Assessment, and Azure Migrate. Server migration. Azure Migrate also integrates with other Azure services and tools and with independent software vendor offerings. In the Azure Migrate Hub, you can assess and migrate on-premises servers and migrate them to Azure virtual machines, assess on-premises databases and migrate them to Azure SQL, assess on-premises web applications and migrate them to Azure App Services, assess your on-premises virtual desktop infrastructure and migrate it to Windows Virtual Desktop in Azure, and migrate large amounts of data to Azure quickly and cost-effectively using Azure DataBox product. The Azure Database Migration Service integrates some of the functionality of our existing tools and services. It provides a comprehensive, highly available solution. This service uses the Data Migration Assistant to generate assessment reports that provide recommendations to you to guide you through the changes required prior to performing a migration. It's up to you to perform any remediation required. When you're ready to begin the migration process, Azure Database Migration Service performs all the required steps. Note, using Azure Database Migration Service to perform an online migration requires creating an instance based on the premium pricing tier. As they often mention in preparation sessions like this, the FAQ links are good sources to review, and one is provided on this slide here for your review. Azure File Sync. Very important topic for this exam is a service that allows you to cache a number of Azure file shares in an on-premises server or cloud VM. The files will be stored in the cloud in Azure File Shares. The Azure File Shares can be used in two ways: by directly mounting these serverless Azure File Shares, SMB, or by caching Azure File Shares on premises using Azure File Sync. Which deployment option you choose changes the aspects you need to consider as you plan for your deployment. In addition to this linked document is a link to an Azure Learning Path. While these are not typically noted, you can find many more learning paths related to studying for this exam at the bottom of aka.ms/AZ-304. And that wraps up design infrastructure for the AZ-304 objectives.